Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about correlation functions. Consider two random variables of a random process x of t. The correlation between two random variables is a measure of the similarity between the variables. Assume that the two random variables are determined at two different times t1 and t2. If the two time instants t1 and t2 are very close together, then the random variables x of t1 and x of t2 will be highly correlated or similar. If the two time instants t1 and t2 are widely separated, the correlation between the values of the random variables x of t1 and x of t2 will be very less. So that is the definition of the correlation function. So basically there are two types of correlation functions. So that are autocorrelation function and cross correlation function. So in this video I am going to discuss about autocorrelation function. And what is autocorrelation function? The autocorrelation function provides a measure of similarity between a given signal and the replica of the same signal delayed by a particular time. The autocorrelation function of a random process x of t is the correlation expectation of x1 x2 of two random variables. So that is x1 is equal to x of t1 and x2 is equal to x of t2 defined by the process at the time instants t1 and t2 respectively. Also consider the time instant t1 is equal to t and t2 is the delayed version of t1 by an amount. So that is t2 is equal to t1 plus tau, but t1 is equal to t, therefore t2 is equal to t plus tau, and tau is equal time difference of t1 and t2, that is tau is equal t2 minus t1. So simply the auto represents two same variables delayed by some time interval. Auto represents two same variables delayed by some time interval. That is tau is equal t2 minus t1. So the autocorrelation function Rxx of, so symbolically the autocorrelation function of the random process x of t is denoted as Rxx of t1 comma t2. So the autocorrelation function of the random process x of t is defined as the expected value of the product of x of t1 and x of t2. So that is Rxx of t1 comma t2 is equal expectation of x of t1 x of t2, which is equal to integral minus infinity to infinity integral minus infinity to infinity x1 x2 joint probability density function of the random process x of t into dx1 into dx2. If t2 is equal to t1 plus tau and t1 is equal to t, then the autocorrelation function of the random process is Rxx of, in this equation substitute t1 is equal to t and t2 is equal to t1 plus tau, we get Rxx of t comma t plus tau. So this Rxx of t comma t plus tau is also denoted as Rxx of tau, which is equal expectation of x of t into x of t plus tau. If the autocorrelation function is determined for two random variables, okay. So before going to this concept, and one of the important point of the autocorrelation function, the physical significance the physical significance of the autocorrelation function Rxx of tau is that it provides a mean of describing the independence of two random variables obtained by observing a random process x of t at times tau seconds apart. It is therefore appearance that the more rapidly the random process x of t changes with time, the more rapidly will the more rapidly will the autocorrelation function Rxx of tau decrease from its maximum value Rxx of 0 as tau increases. If the autocorrelation function is determined for two random variables observed on the same time, that is t1 is equal to t2 and t2 is equal to t, so then the value of the autocorrelation function represents the average power of the random process x of t. So that is Rxx of, and what is the basic definition of the autocorrelation function of the random process? Rxx of t1 comma t2 is equal expectation of x of t1 into x of t2. That is the basic definition of the autocorrelation function of the random process x of t at two time instants. So now here the autocorrelation function is determined for two random variables observed on the same time instance. And what is that same time instant? T1 is equal to 2, T1 is equal to T2, T2 is equal to T. So Rxx of T comma T is equal expectation of x of t into x of t. So in this equation, substitute T1 is equal to T and T2 is equal to T. We get Rxx of t comma t is equal to x of t into x of t, x square of t, expectation of x square of t. So expectation of x square of t is the average power of the random process. Average power of the random process. So this is the concept of autocorrelation function of a random process.